Hello, our topic for the unit design project is linear equations. Specifically, our students will be writing and graphing linear equations using slope-intercept form. This is a 6-day unit. 5 of those days will include instruction, with the 6th day being focused on the summative assessment. Students will learn how to graph linear equations appropriately, along with understanding what each part of the equation represents in a 6-day unit. The equation students will see is y equals mx plus b. Students will learn that the m represents the slope and the b represents the y-intercept. Along with identifying the parts of this equation, students will focus on graphing linear equations, discovering the pattern in a graph, and how changing the slope and y-intercept affect the movement of a line. 6 periods of 7th grade students will experience this lesson. The class size ranges from 20 to 27 students. We have students of varying abilities. There are a total of 12 English language learners within 3rd, 4th, and 9th period. There are a total of 10 students who have 504 plans in 3rd, 4th, and 7th period. Prior to this lesson, students should be able to understand what a coordinate point is, how to graph them correctly, the 4 quadrants of a coordinate plane, where to locate the x and y axes, and additionally that x represents the independent variable and y is the dependent variable. In this lesson, students will be able to identify key components of a linear equation and graph a linear equation in slope-intercept form. They will achieve these goals through the simulations of PhET and explore learning gizmos for exploration and practice, as explained later on. We use Brewer's Thinker Tools approach to aid in our lesson design. Brewer's first step of his approach is to motivate. Students will be motivated during day 1 of our unit. We will be looking at PhET graphing slope-intercept simulation. During this activity, students will be working in pairs and focusing on changing 2 colored points, which represent 2 points on the line. Through this exploration, students will need to come up with their own questions and observations, which we will discuss at the end of class. This will provide students with the opportunity to explore and apply prior knowledge without the teacher guiding their thoughts. Any questions and misconceptions will be addressed during the unit. Step 2 in Brewer's approach is model evolution. This will be addressed on days 3 and 4. Students begin by looking at the gizmos, where they are forming a foundational understanding of linear equations. The gizmos allows them to move points wherever they choose on a graph. On the following day, we will discuss the importance of the y-intercept being located on the y-axis. This will be done through pencil and paper. This allows us to formally assess how many students understand the y-intercept point and can accurately plot it. On day 3 and 4, they will use the PhET simulation to help extend their learning. Step 3 in Brewer's approach is formalization, which will take place on days 3 and 4. During this time, students will directly watch how changing the slope and y-intercept affects the function of an equation and how the equation matches a table. At this point, they should understand the parts of the equation, but may not fully understand how the components can affect the graph, table, and equation altogether. Step 4 in Brewer's approach is transfer, which will take place on days 4, 5, and 6. Students will be working with the gizmo simulation and worksheet. Students will follow the worksheet to practice plotting points, using an input and output table, and writing the equation of a line. This activity is extending their knowledge because they are answering questions in more real-world situations and putting all of the pieces together that they have been practicing. On day 5, they will review the learned concepts through a review scavenger hunt around the room prior to their summative assessment on day 6. Another theory that was taken into account when creating this lesson was the cognitive theory. This theory is applied in our design through the inclusion of online interactive software that allows students to manipulate points on a graph and make observations and connections. The use of the software will stimulate their senses and allow them the information to be stored based on manipulation. Due to the different learning styles and abilities in the classroom, students will store and apply information differently. Through the exploration format of this unit, the teacher takes on a facilitator role and can guide the learning based on the needs of each group of students through the transfer process. The main technology used will be gizmos and PhET interactive simulation software. The gizmos, titled Points, Lines, and Equations, allows students to manipulate 2 points on a graph and view how the line changes. When the student moves a point, its new coordinate is given at the bottom of the page. The PhET simulation, graphing slope-intercept, allows students to change 2 points on a graph through the manipulation of the slope, as shown here. These tools will be used to motivate learners to make observations and develop questions at the beginning of the unit, as well as a tool to practice the learned skills throughout. The tools add value to the unit by allowing the user to easily see how the slope and y-intercept of a graph change how the graph looks. These tools will increase engagement for the learners, as well as meet the unique learning styles and instructional needs of each student. We will also be utilizing Schoology for posting assignments in YouTube as a resource for students to refer back to if they need reteaching or additional explanation. Here is our day-to-day plan. Day 1 is a day of exploration, observations, and students independently forming questions. Students will walk into class and we will review the key concepts of this lesson that students have had exposure to. What coordinate points are, how to graph coordinate points, and how to write them, quadrants of a coordinate plane, and the difference between the x and y axes. After this review, we will instruct the students to go to the Explore Learning Gizmos. Then on here, students' goal is to play around with the simulation by changing the slope and y-intercept. Through the exploration, they are observing how the graph changes as they manipulate the numbers. After some time working on this alone, they will pair up with a partner and share what they have discovered. We will then come together as a class and discuss what students have discovered, share questions, and possible answers. On day 2, we will be introducing linear equations and key vocabulary using a foldable. Linear equations are in the form y equals mx plus b, which is referred to as slope-intercept form. Students will learn that the m represents the slope of the line and b represents the y-intercept. On Schoology, students will have access to resource videos that can be viewed when they are in need of review or just need a refresher of the information. On day 3, we will start the class reviewing the information learned on day 2. This day is dedicated to discovering formally how the slope and y-intercept affect both tables and the equation of a line. Students will be given a handout that will help guide them through the PhET simulation as shown before. Day 4, students will be working through a handout that goes along with the Explore Learning Gizmos to practice writing and graphing linear equations. As students work through this gizmo, they will be solidifying their knowledge of coordinate points, slope, and y-intercept as they are writing and graphing linear equations. The focus of day 5 is to review before the student's summative assessment. The review will be through note cards around the room that will be placed on the walls and desks. Students will have a sheet of paper that will help prompt them in order to be in contact with each note card around the room. In this scavenger hunt, students will begin at a note card of their choice and answer the given problem. If correct, their answer will be posted on another note card around the room and they will advance to the next problem. Here's an example of what the note cards will look like. Below is the question that this student is starting at. Identify the y-intercept in the following equation. The correct answer would be b equals 4. Hanging around the room will be a large answer, b equals 4, on one of the note cards. This will be the card that they will go to next. Underneath that answer will be their following problem. This problem will then lead them to the next answer, and so on and so forth. If they have done it correctly, they will end back with their final answer being the answer on the note card that they started at. The format of this document is designed to help the teacher and students check their answers so they can always be formatively assessing. The teacher, if they want to provide a quick answer key or check a student's work, can look and see here is the answer to the question that was on the previous page. Here is the question, and here is its answer. On day 6, students will be given the opportunity to ask any final questions for the first 5 minutes of class, but the focus of the day will be on the final assessment. Within the PhET online simulation, there is a game called Line Game. Students can pick from levels 1, 2, 3, or 4. Here is how I would access the Line Game. Here are my different levels. These levels grow in difficulty as a student progresses. The lowest level asks students to graph the line given the equation or identify one part of the line, such as the y-intercept. For students in need of enrichment, level 4 requires students to identify all parts of a linear equation based on the given graph. This level is for students almost ready to graph on their own without the use of the simulation. In all levels, students must press the check button to see if their answer was correct. They will receive a happy or a sad face and will either advance or repeat the level as needed. This provides students with formative feedback without the need of the teacher directly. The major assistive technology that will be used during this unit to make the material accessible to a broader audience is an iPad. On the iPad, students can utilize programs such as Notability and Explain Everything to take notes, record audio, share thoughts, and complete assignments. This will aid students who struggle with fine motor skills when writing and allow students to review material as many times as necessary. Through the iPad, students may also video record class lectures for the same use as audio recording. These tools can be used for formative assessments, as part of group discussions, and as a mode to reteach information. Students will also have access to the class Schoology page, where YouTube videos will be posted related to identifying parts of graphing a linear equation in slope-intercept form. Having these resources available at all times allows struggling learners to review material and provide a mode of reteaching as needed outside of the classroom. On this slide, you will see that there are several links to student handouts on the left-hand side and the student work examples on the right-hand side that will be used throughout our unit. We will be providing the handouts to students digitally and as a hard copy. Allowing both formats helps students with differing abilities to show their work in the format that best suits their needs. We will post each assignment individually on Schoology, but in addition, we will provide the online resource document to students. The PhET activity is an example of modification during the unit because students are able to see a change in a graph immediately after changing the slope or y-intercept. Through the use of online simulations, students are able to identify and graph parts of an equation through online manipulation, which provides them with immediate results. They are able to make observations about the slope, y-intercept, and how it directly affects the graph. This leads to an increase in student discussions in regards to noticeable patterns. Students can additionally see how the y-intercept is placed on a graph correctly each time a new equation is inputted. This is especially important since many students struggle with this coordinate point. If this were done on paper, students would have to go through multiple steps and use a lot of time to see this relationship, and sometimes, unfortunately, losing sight of what the concept they were supposed to understand actually was. To assess student learning of content, students will complete 2 worksheets that coincide with the simulations. While students are working through our notes and handouts, we will be able to informally assess the success of our students and provide feedback as necessary. To receive further formative feedback of student understanding, students will create an Explain Everything video document with a partner where they will verbally explain the graphing process as if they were explaining to a peer. Data will be used to guide future lessons. To assess the effectiveness of the unit's design, we will look at the success of our students on the final test. The goal is that 80% or more of the students will receive an 80% or greater, which is 16 out of 20 points, on the final assessment. The reason for this is because 4 of the 20 points represent extension problems where students are able to show us whether they have met or exceeded the standards being assessed.